All right, today we are going to be talking about indirect measurement while we're still dealing with our similar triangles. And so the indirect measurement, you're going to notice, are kind of using some real life examples using our similar triangles that we talked about last. First, what is indirect measurement? All right, you're going to have to add this to your notes. Indirect measurement is finding a distance or a length of something by using properties of similar triangles. Or trigonometry, you will notice similar problems pop up in chapter 12, our next unit. So indirect measurement is when we're trying to find like a length or a distance of some taller or longer shapes. Like for example, if you have a tree in your yard, like the one shown here on the left-hand side of the screen, you can technically find a pretty good estimate on how tall that tree is by using similar triangles. By using the shadow as one of the lengths, and then if you have, let's say, a wall here and that same shadow from that same direction, and then you can use that to set up a proportion. So I'll be showing a few different examples, but a shadow is one way that we use indirect measurements. We can use shadows, and we can also use mirrors to help us. So let's say I'm at the Eiffel Tower here as shown, and I want to get a good measurement. I put a mirror on the ground somewhere between me and the Eiffel Tower, and the goal is when I look into the mirror that I see the top of the Eiffel Tower in that mirror. Okay, so that you're seeing the top. So those two sides would be proportionate. So you can use then your distance from the Eiffel Tower to the mirror, and then your distance to the mirror to help you. Obviously, you know how tall you are, so you can set up a proportion to figure out how tall the Eiffel Tower is. And yes, this actually works, and there is an activity that we do involving a mirror and finding different lengths of that. All right, so let's get started on this first example that was shown on the last one. Okay, so if you're out in your yard today, you can go and find the height of a tree or an approximate height, and the sun's got to be shining first because we have a shadow here. Okay, and then you could use yourself, or you can use a wall or another object like the one here they have shown. Okay, so we can set up a proportion. We've dealt with proportions throughout this chapter so far. Okay, so we have the height of the tree, which is our unknown. Its shadow is 24 feet. Okay, and then we have the height of the wall, which we know is 4, and then the shadow to be 6. Okay, so notice that I left the proportion. I have the shadows lengths on the bottom, and I have the height lengths on the top. Okay, and then we can just cross multiply. Okay, so we can take 24 times 4, and we get 96, and divide that by 6. So the height is approximately 16 feet. Okay, so that means this tree is about 16 feet tall. All right, here's another example. Okay, so we could also, if we wanted to go outside the school here and find out how tall the flagpole is, we could do very similar, okay, where we have the height of the flagpole. We know its shadow. They gave us this length to be 8, and we know it would have to be proportionate to us and our shadow. So let's say we are 6 feet tall, nice and tall, and our shadow is about 10 feet. Okay, so again, we can do our cross multiplication, 85 times 6, and then divide by 10. So our height of our flagpole is about 51 feet tall. A lot taller than our tree was in the last example. Right, so here would be kind of like a mirror example. Okay, you could pretend that we have a little mirror here. Okay, and we want to know the height of whatever object is over there, so we can set up a proportion with our similar triangles. So we have the height, its distance to the mirror is 500, the height of the other object, and then the distance to the mirror. Okay, and we do some cross multiplication, 500 times 1.8 divided by 2.75. So this height would be approximately 327.27 meters tall. Okay, we multiplied and then divided. Sometimes these will show up in word problems, so it's your job to draw a picture out. Okay, we have a sunny day, so sunny day means there are shadows, so we're probably going to have a shadow problem. Okay, anytime I kind of realize it's going to be a shadow problem, I like to set up two triangles, just like that. Okay, we have a 36-inch yardstick casts a 21-inch shadow, so we have 36 inches. We'll call this my yardstick. And it has a 21-inch shadow. How tall is the building whose shadow is 168 feet? So notice this was inches, and this says feet. So I'm going to convert 168 to inches to make it easy, since I already wrote out the other part of the problem. So this is the same thing as 2016 inches. So 2016 inches. I have to be in the same, they have to have the same label on them. Okay, so we're going to set up a quick proportion here. 2016, 36, and 21. And then we're going to do our cross multiplication. Divide by 21. 3,456 inches tall. Okay, now we can convert that back to feet, which would be 288 feet. I think feet's always easier to kind of visualize. When we're dealing with like a building, you don't really say, oh, it's 3,456 inches. Okay, we would like to say 288 feet usually. All right, next and final one, we have a 4-foot person, 4 foot, standing near a telephone pole, near a telephone pole that has a shadow of 3 feet long. At the same time, the telephone, so this was the 3 feet was the person. The telephone pole has a shadow of 18 feet. How tall is the telephone pole? Okay, pause the video and take a second to try this one on your own if you haven't done one on your own yet. Pause the video. Okay, so when we set up our proportion, it should look like this. 18 times 4 divided by 3. Our telephone pole is 24 feet tall.